Hi, today we'll be talking about electric charges and electric fields.
Bit of a ball. He means well.
When people think of electricity, they often think of the applications for modern technologies such as computer, television, lights, and electric power. But where does electricity come from? It comes from individual charged particles which Benjamin Franklin originally called positive and negative.
That makes it simpler.
As far back as a few thousand years ago, the Greeks noticed that when you rubbed amber with fur, it attracts small objects such as straw. Here we're going to reproduce that simple experiment by using glass rods and rubber rods, which when rubbed with different materials are charged either positively or negatively. It's just like when you walk across a carpeted room and you get shocked after you touch the doorknob.
That rug will be charged with 4,000 volts of electricity the moment that I go through that door.
The rod is suspended and can rotate freely. With this setup, we will see a fundamental property of charged particles. Unlike charges attract, while same charges repel each other. A negative charge is created on a rubber surface by rubbing it. When you put these close to each other, they repel.
That guy ain't no magician.
On the other hand, the glass rod is charged positively by rubbing it with silk. And we see the rubber rod moves towards the glass rod, since now they have opposite charge. Unlike charges attract, while same charges repel each other.
The two known facts fit together. Yes, that's up.
The fact that opposite charges attract is what binds atoms together. Negative charges, known as electrons, orbit around a central core of positive charges, known as ions, just like gravity holds planets in orbit around the sun. Charles Coulomb showed that the electric force, just like the gravitational force, decreases as 1 over the distance squared and is proportional to the product of the charges involved. But how do electric charges affect each other even though they're not touching?
Don't answer now. Think it over.
One way to understand this is to imagine that charges produce an electric field in the space surrounding the charge. We can visualize this electric field by using this apparatus here, which consists of charged probes and an oil containing metallic shards. The probes can be given opposite charge, and the electric field line pattern is formed by the metallic shards in the oil. When the probes are oriented such that they have opposite charge, you can see the electric field line pattern that is formed.
That's a splendid achievement, son.
Here on the computer with MEPI, we can simulate charges and examine the electric field lines for more complicated charge arrangements. For example, here we have 3 charges, and you can see the field line pattern. With MEPI, we have the freedom to add more charges, and we can move them around as we wish. This is something that cannot easily be done in a real lab.
Get me out of here! Get me help!
When a charged particle is placed near another charged particle, they exert a force on each other through the electric field, and they either attract or repel each other, as we saw with the hanging rods. The force is equal to the charge times the electric field. We can use MEPI again to show this. For 2 positive charges, we see that when the particles are released, they move away from each other due to the repulsive force. When 3 charges are present, 2 of which are positive and 1 which is negative, the particles follow much more complicated trajectories. The electric force is fundamental and everywhere in nature. It affects our everyday lives, from DNA structure to electrical storms.